Eaton Corporation. Service Training presents the EV-1 SCR Drive Control Training Program. In this program, we will take a look at all of the components used in the EV-1 control, their location, and their test specifications. Also, system operation and troubleshooting procedures will be explained by looking at each of the circuits that make up the EV-1 system. Three styles of EV-1 control panels are used on Yale electric trucks. They are the Model B, 200 amp, Model C, 300 amp, and Model D, 350 amp panels. This program will cover the components used on the Model B panel, since it is the most commonly used panel. The EV-1 and GE Model 100-500 SCR controls are very similar, except that the EV-1 contains standard features that were optional in the former controls. Some of these features are pulse monitoring trip, 1A thermal hold-off, static return to off, and ramp start. The addition of these features significantly changes troubleshooting procedures. Some new components have been added to the EV-1 control, and others have different shapes from former controls. In the following slides, we will look at each component's features and its location on the truck and wiring diagram. The main SCR, or 1-rec, looks much different from most SCRs. The rec is actually a hockey puck type SCR mounted between two heat sinks labeled anode and cathode. Note the gate terminal on the side of the rec and the thermal protector mounted in the cathode heat sink. Both 2 and 5 recs have a stud or anode terminal, a white gate lead, a black cathode, and a red auxiliary lead. These SCRs are mounted on the end of the panel, with the 2-rec being slightly larger than the 5-rec. 2 snubbers, labeled 22 and 25 recs, are connected in parallel to 2 and 5 recs. Inside the blocks are resistors and capacitors used to suppress voltage spikes that may occur during circuit operation. Both snubbers are identical and interchangeable. The flyback and plugging diodes are mounted in the center of the panel. Although the 3 and 4 recs look similar, they have different amperage ratings and therefore are not interchangeable. Also, the polarity of these diodes is opposite to the 3 or 4 recs used on the Model 100-500 panels. Interchanging diodes between the two controls will result in a dead short in the control. The capacitor 1C is mounted adjacent to the 1-rec. Before working on the electrical system, always unplug the battery and discharge the capacitor by shorting a metallic object across the capacitor terminals. Beneath the capacitor lies the transformer, which also serves as the mounting block for the 2 and 5 recs and the snubbers. Note the terminals for the primary winding T1 and T2 and the secondary windings T3 to T4. Also located within the transformer block is the choke coil, labeled 1X on the wiring diagram. Two other voltage spike suppressors located on the panel are the 23 filter and 23 resistor. The 23 filter is a capacitor connected parallel to 3 rec, and the 23 resistor is a 5 ohm resistor connected parallel to the 1X choke coil. Shown here is the sensor which feeds load current information to the control card. The metal sensor bar connects the center power terminal to the 3 and 4 rec heatsink. It is easily recognizable by the yellow and green leads which are soldered to the back of the bar. The control card is represented on the wiring diagram by its 3 plug connections. The left and right terminal strips are located on the face of the card, while another plug, numbered 1 to 14, is mounted on the rear of the card. All of the color-coded wires on the panel connect to the rear plug. The card is mounted on hinge-type brackets on top of the panel. To remove the card from the panel, release both hold-down clips. Tilt card to a 10-degree angle, and then slide card out of the brackets. To remove the left and right terminal strips, first loosen the 4 corner hold-down screws, and then pry the terminal strips loose by twisting a screwdriver in the slot provided. The rear card plug also has a screwdriver slot and 2 hold-down clips, which must be compressed while twisting a screwdriver in the slot. The rear color-coded plug is numbered only at the ends of the rows. In other words, 1 and 5, 6 and 9, and 10 and 14 are marked. Reading the numbers upside down may result in confusion between terminals 6 and 9. Refer to the wiring diagram colors with terminal numbers. 8 card adjustment pots are located under the cover. The resistance variation from a pot setting of 1 to a setting of 9 is very slight, so that a truck cannot be damaged by a maladjusted card. Following is a list of pot settings for all truck models. The creep pot should be set so that the drive wheels begin to rotate when MS1 is closed. Control acceleration should be set on the number 7. Current limit on 9, 1A time on 3, and 1A dropout on 9. The plugging should be set so that the truck travels at a minimum of 1 1/2 times its length before reversal when the truck is plugged. The field weakening pickup and dropout should be set on 9. Shown here are the forward, reverse, and 1A contactors used on the EV-1 control. Tip sizes have recently been standardized for all truck models, as stated in Service Bulletin SE 914. Note also that the coil is polarity sensitive, as indicated by the plus sign. 2 fault detector modules labeled PMTD and 1AD are wired in series with the contactor coils. They control current flow through the coils in conjunction with the control card's pulse monitoring trip circuit. If the card sees a runaway speed control fault, it will turn off the driver, which in turn opens the contactors. The hour meter diodes and directional switch assembly is located on the steering column just above the steering control valve. The accelerator box contains the MS1 start switch, the MS4 1A switch, and the accelerator pot. Current production trucks will have the Sigmanetics assembly shown on the right. See Bulletin SE931 for this product change. We will now cover the testing procedures of the components that make up the EV1 control using a multimeter, such as the Simpson 260 shown here. Additional information on the use of a multimeter and component testing can be found in sections 2 and 3 of the Electrical SCR textbook, which is available from the Training and Development Center. The 1-rec is tested using the following 4-step process. First, set the meter scale on R times 10,000 and connect the black meter lead to cathode and the red meter lead to anode. Meter readings should be more than 100,000 ohms. Then, reverse meter leads for step 2, and readings should again be more than 100,000 ohms. In the 3rd step, set meter scale on R times 1 and connect the black lead to cathode and the red lead to gate. Readings should be between 10 and 80 ohms. Then, reverse leads and readings should be more than 5 ohms. If the SCR passes all 4 of these tests, it should be good. The 5 and 2 recs can be tested in the same manner as the 1-rec, except that both the red and black cathode leads must be checked in the 4-step process. Also, check for intermittent opens in the wires with the meter connected. The 3 and 4 recs and the hour meter diodes should be connected on the R times 1 scale. Reading should be 5 to 25 ohms with black lead on cathode and red lead on anode. Reverse leads and reading should be infinity. Both transformer windings should have a very low resistance reading of 0 to 1 ohms. The choke coil should be checked in the same manner as the transformer with a meter reading of 0 to 1 ohms. The capacitor can be checked on the R times 10,000 scale. The meter needle should deflect towards 0, then swing up to more than 100,000 ohms. Switch leads, and the meter should repeat this charging up pattern. The filters or snubbers labeled 23, 22, or 25 recs can be checked in the same manner as the larger capacitor. However, the meter needle will deflect much faster for these smaller capacitors. Test the sensor from the yellow to green wire at the card plug terminals 13 and 14. Meter should show 0 ohms on the R times 1 scale. Also, check the thermal protector at the card plug where the orange and brown wires connect to terminals 11 and 12. Ohm readings should be 0 to 200 at room temperature. The forward and reverse contactor coils can be checked on the R×1 scale. The meter should read approximately 25 ohms in one direction and 15 ohms in the other because of the suppression diode mounted internally in the coil. The 1A coil should read approximately 30 ohms on the R×1 scale. On some trucks, the coil will have 30 ohms resistance in both directions. We'll have 1A coils that will read 30 ohms in one direction and infinity in the other. Two quick checks can be made to verify if the card is bad. Check for continuity between R4 and terminal 6 on the rear plug. An open in this circuit indicates a bad card. Also, a strong burnt odor in the vicinity of the rear card plug indicates a blown card. Accelerator pot resistance can be checked at card terminals R4 and R5 or right at the pot. Ohm readings should range from 4,800 to 6,000 ohms at MS1 and then decrease to 0 as the accelerator is moved to the MS4 position. Now, let's take a look at the role each of these components plays in the SCR circuit. The 1-rec is the main switch that connects the battery to the drive motor. The speed of the motor is determined by how fast the 1-rec is turned on and off. The 1-rec is turned on by the card's gate signal and off by the turn-off circuit, which includes the 5-rec, 2-rec, transformer, capacitor, and choke coil. First, the 5-rec turns on to allow the transformer to charge up the capacitor. Since the transformer steps up voltage, the capacitor is charged higher than battery voltage. Then the 2-rec turns on to discharge the capacitor opposite to the battery current flowing through the 1-rec. The effect of these opposing currents is to turn 1-rec off. The choke coil in this circuit protects the 2-rec from being damaged by the sudden discharge of the capacitor. This sequence repeats itself to produce the on and off pulsing pattern shown here. The fact that no battery power is wasted during the off time of 1-rec is one reason that the SCR system is 90% efficient. The 1A contactor provides full speed. Since the SCR circuit is designed to provide only 80% of maximum truck speed. When the 1A contactor is closed, current bypasses the SCR circuit to apply full battery voltage to the drive motor. The 3-rec, or flyback diode, reroutes current that is generated by the motor during the off time of 1-rec back through the drive motor. This flyback current is another factor that makes the SCR control so efficient. Plugging, or soft reversal of the truck's direction, is provided by the 4-rec diode loop. When the directional switch has been reversed, plugging current is present in the 4-rec loop. The card will sense this current through the sensor and subsequently slow the pulse rate of 1-rec to provide smooth electrical braking. Shown inside the red square is the control circuit whose primary purpose is to operate the contactors, vary truck speed, turn on the SCRs, and provide fault detection. Note that the control circuit wires are thin compared to the thick, heavy lines of the power circuit located above the red square. Control current flows through the 10-amp fuse and then the key, seat, brake, MS1, and forward or reverse directional switches. Voltage will then be present at the selected contactor, coil, and PMT driver. If the switches are functioning properly, battery voltage will be fed to the L terminals 3, 4, 5, 7, 9, and 10 of the card. The switches must be closed in the proper order to satisfy the card's static return to off logic circuit. This is a safety feature that prevents reoperation of the truck if the directional switch is left in operating position when the seat switch is opened. When all switches are closed, the card sends a 2-volt signal from R3 to terminal 1 of the PMT driver. This signal turns on the transistorized driver, which allows current to flow from either terminal 3 or 4 of the driver to terminal 2, which is negative. The current flowing through the contactor coil and PMT driver magnetically closes either the forward or reverse contactor. At the same time, the card will send a signal to the 1-rec gate. Current then flows from the battery positive through 1-rec, motor fields, armature, and back to negative. Then the turn-off circuit, discussed earlier, goes to work to turn the 1-rec off to repeat the pulsing cycles of the SCR control. The pulse rate is established primarily by the position of the accelerator potentiometer. The oscillator circuit of the card, which is responsible for the 1-rec gate signals, is directly controlled by the accelerator pot's resistance. The thermal protector, which monitors heat buildup in the 1-rec, will also slow the pulse rate of the 1-rec if the SCR overheats. This allows time for the 1-rec to cool off. When the MS4 switch is closed, the card sends a 2-volt signal from R8 to terminal 1 of the 1A driver to turn it on. The 1A coil will now energize to close the 1A contactor. The SCR circuit is bypassed and the truck will run full speed. The card will automatically turn the 1AD on if the 1-rec is conducting 80% of the time. This is called 1A demand pickup and does not require the use of the MS4 switch. Also, the card will not allow the 1A to operate at all if the truck is in thermal cutback. The card's pulse monitoring trip circuit will not allow signals to be sent out to the PMTD or 1AD if a fault occurs that would cause a runaway truck. If the truck is in operation and one of these faults occurs, the PMT voltage will disappear and the forward or reverse contactor will drop out. Faults that would cause a PMT trip are a welded 1A contactor, a shorted 1-rec, or a faulty component in the turn-off circuit. The card's PMT circuit determines faults by splitting the battery voltage into 2 halves from T2 to positive and T2 to negative when the key switch is closed. A 36-volt system would be split into approximately 18 volts on each side. A PMT fault will cause an uneven voltage split. If the 1A contactor is welded, or if the 1 rec is shorted, there will be 0 volts from T2 to positive and full battery voltage from T2 to negative. When the PMT logic circuit of the card sees this lopsided voltage split, it will not send any voltage signal from R3 to the PMT driver, and no current will be able to flow through the contactor coils and the PMT driver. A faulty turn-off circuit will not show a lopsided split until the 1 rec initially turns on. Then the PMT will double trip the contactors. This double trip action is referred to as the look again feature of the card, which is designed to prevent a random voltage spike from disrupting circuit operation. The PMT function can be reset by returning all switches to the off position. If the contactors double trip after the PMT is reset and the switches are reactivated, the problem is definitely in the turn-off circuit. Troubleshooting system malfunctions on the EV-1 control is simplified due to the way the switches and various other components are wired into the L and R terminal strips. Also, the PMT operation of the control helps to isolate problems quicker. In the following slides, we will look at some of the more common symptoms and then some of the voltage or resistance checks that you can make to locate the cause of the symptom. For more detailed troubleshooting procedures, refer to the Electrical SCR Manual, STL 1207, that is available through the Training and Development Center. When making voltage checks that will be mentioned in the following slides, it is assumed that the black meter lead is always connected to the negative power terminal, as shown here. The red meter lead will be moved to various locations to check for positive voltage potential. Before troubleshooting, observe the following procedures. Jack drive wheels off the floor. Check battery charge condition. Check battery polarity. And visually inspect the electrical circuits for obvious faults like broken wires, bad plug connections, and welded contactors. The first symptom we will look at is also the most common problem on the EV-1 control because of the PMT function. The symptom is contactors do not close, so no SCR speed, no 1A. Manually close the 1A and either the forward or reverse contactor. The motor should now run. If not, check the circuit shown in red, which includes the battery and plug, main fuse, contactors, and the motor. If truck does run, continue to the next step. Check for positive battery voltage at each of the L terminals 3, 4, 5, 7, 9, and 10 as each switch is activated. If voltage is not present at one of the terminals, check the switch and the wiring that is connected to that particular terminal. All terminals should read 0 volts before its input switch is closed, except for terminal 5, which should read 80% of battery voltage before MS1 is closed. After MS1 is closed, the meter needle should swing up to full battery voltage. If it doesn't, check MS1 and the normally closed brake switch for proper operation. With all switches closed, check the voltage at R3 on the card. If a reading of 7 to 8 volts is obtained, either the PMT driver is bad, or the wire from R3 to terminal 1 of the driver is open. If the voltage at R3 is 0, check the voltage split from T2 to positive and T2 to negative. Make sure the key switch is closed before checking voltage split. Remember, each side should read approximately 1/2 battery voltage. If the voltage is lopsided and there are 0 volts from T2 to positive, check for a welded 1A contactor or a shorted 1 rec. If no faults can be found, replace control card. Also, if the voltage split is even, but there is no voltage from R3, replace the card. The next symptom is similar to the preceding one, except that this time the directional contactors do close, but there is no power and no SCR hum. Again, manually close the 1A and forward or reverse contactors. If truck does not run, check circuit shown in red, which is the battery, plug connections, main fuse, contactors, motor fields, and armature. If truck does run, proceed to next step. Check operation of the accelerator pot at R4 and R5 on the card with one of the wires removed. Remember, the resistance should be approximately 5,000 ohms at MS1 and gradually decrease to 0 ohms at MS4. Check 1 rec for an open condition or no gate signal from the card. Also, check the 2 rec for an open condition or no gate signal from the card. Check the green wire from the sensor to the card plug and the transformer primary T1 to T2 for an open. If all of the above items check good, replace the card. The next symptom is contactors close, little or no power, low SCR hum, and no 1A. Check the following items circled in red on the wiring diagram. The accelerator pot adjustment and operation, the 4 rec for a shorted condition, an open or heated thermoprotector, and a shorted 2 rec. Another symptom that may occur is the contactors will double or single trip every time the PMT function is reset. The problem in this case would be in the turn-off circuit, which would include the 2, 5, 22, and 25 recs, the capacitor, transformer, choke coil, and 23 resistor. The most common problems are the 22 and 25 rec snubbers. If both snubbers check good, sometimes interchanging their positions on the panel will solve the problem. If the truck has normal or slower than normal SCR speed, but no 1A, check the following items. First, make sure there is battery voltage at terminal 3 of the 1A driver with the key switch on. This checks the 1A coil and wiring from the key switch to the driver. Then check voltage from R8 with the accelerator pedal in the full speed position. If 7 to 8 volts are present, either the 1A driver is bad, or the wire from R8 to terminal 1 of the 1AD is open. If there are 0 volts from R8, check the MS4 switch, thermoprotector, and the violet wire from T2 to the card plug. Replace the card if all of these items check good. As mentioned before, these are the most common symptoms of faults on the EV-1 control. Several other miscellaneous symptoms may occur, and these are mentioned in the troubleshooting guide of the Electrical SCR textbook. There is also an Ev1 Analyzer available, which can be used in conjunction with a volt-ohm meter to check out all circuits and components in the drive control except for the 4 rec. If everything checks good using the analyzer, then it is assumed that the card is bad. The analyzer can be ordered by using part number 5180968-17. This concludes the EV-1 Control Training Program.